Hello students. So now we are going to start discussing the problem from previous years and some important problems. The first problem is from 1997 AIPMT. The center of mass of system of particle does not depend on. I told you in theory slides, the center of mass is sigma mr upon sigma m. It means all is the game of distribution of mass only. So position of particles, it is correct answer. Distances between the particles, it will depend on that. Masses of the particle, yes, their role is also there. Forces acting on the particle, no role was there. RCM was only sigma Rm upon sigma m. So which answer should be correct? Definitely you can tell D option is correct because center of mass does not depend upon forces acting on the particle. Second one, again one theoretical problem. It is from 1999 AIPMT. 3 identical metal balls, each of radius r, are placed touching each other on a horizontal surface such that an equilateral triangle is formed when center of 3 balls are joined. The center of mass of the system is located at, we know that, what they are saying. We have suppose I am taking this equilateral triangle. I am taking the help of coordinate. It is my x-axis, it is my y-axis. If I put a perpendicular from A on this, it will go at midpoint. It means this is origin, which should be midpoint. If coordinates of C are 1, 0, the coordinates of B should be -1, 0. It means length of this side is 2. So length of this side should be 2. What should be the coordinate of A? Coordinate of A are, it is on y-axis, so x coordinate should be 0. What should be its y coordinate? We can calculate by Pythagoras theorem. It is 2, it is 1, under root 4 minus 1 root 3. It should be root 3. So now I can calculate the x coordinate of center of mass. I am going to tell you what is the x coordinate of center of mass. 3 identical balls are at this place, and mass of ball I am taking m. So xcm, since I am talking about x coordinates, so I will take x coordinate of all the points m1 x1, m1 x1, m2 x2, m3 x3, m plus m plus m. What I am getting? 0. So x coordinate of center of mass, I got 0. I am going for center of mass of y coordinate. Y coordinate of center of mass. m1 y1 root 3m. m2 y2 0m. m3 y3 0 into m upon 3m. So what I am getting? I am getting y coordinate of center of mass cancel m with m, you will get 1 by root 3. So it means your center of mass is at a point whose x coordinate is 0 and y coordinate is 1 by root 3. And see, what are the medians? What is the centroid? What is the centroid of this triangle? You know the formula from 9th class. X coordinate of centroid should be x1 plus x2 plus x3 by 3. You will get 0. Y coordinate y1 plus y2 plus y3 by 3. You will get 1 by root 3. It means it is a centroid. And which point is centroid? Centroid is the point of intersection of medians. So I will go with option. The point of intersection of the medians means we are going with option C. We are going with option C. Next. A very good problem from 2002 AIPMT. A rod of length 3 meter and its mass acting per unit length is directly proportional to distance x from one of its end, then its center of gravity from that end will be at. A rod length is 3 meter long and its mass acting per unit length means dm by dx is directly proportional to distance x from one of its end. What they are saying? They are saying कि dm by dx is directly proportional mass per unit length is distance of that portion from one end. If you remove the proportionality sign, you will get one constant kx. Since it is a rod, a continuous distribution of mass, so we have to take the help of integration. What I am doing now, I am taking from one end at x distance a small piece of rod of length dx. Its mass should be small. I will calculate the mass of this. We know that center of mass in this case is equals to total distribution of mass. Suppose I am giving you formula. I am taking length L. So 0 to L. First I will calculate for this. What is the mass of this piece? Unit length has mass dm upon dx. And I took the length dx. So it is mass and sigma mr and distance is x divided by 0 to L mass. Mass of this is unit length mass dm by dx and its length is dx. So what I am getting now, 0 to L, dm by dx is kx, kx into x, kx square. Divided by, it is kx dx. Cancel k with k, it is constant, it will come out of the sign. And integration of x square is x cube by 3. And integration of x is x square by 2. In place of x, I am putting L. So, in numerator, I will got L cube by 3 divided by L square by 2. So, I am getting 2L by 3. In this case, L is 3. So, 2 into 3 by 3. So, I am getting 2 meter. It means you will find your center of mass at a distance of 2 meter. You will find your center of mass at a distance of 2 meter from this end. Next, a solid sphere of radius r is placed on smooth horizontal surface. A horizontal force F is applied at height h from the lowest point. For the maximum acceleration of center of mass, which is correct? Since surface is smooth, what they are saying? Surface is smooth, frictionless. So, no rotational motion is there. No relation between H and R. So, we are going with option D. We are going with option D. Next, from 2004 AIPMT exam, again a very good question. They are saying consider a system of two particles having masses m1 and m2. If the particles of mass m1 is pushed towards the center of mass of particles through a distance d, by what distance would the particle of mass m2 move so as to keep the center of mass of particles at the original position? It means, what did you want? You want no motion of center of mass. You want that velocity of center of mass should be 0. Otherwise, it will move from its original position. So, you want, in this two particle system, we know that the velocity of center of mass should be given by m1 v1 plus m2 v2 divided by m1 plus m2. We need, it should be 0. It means m1 v1 plus m2 v2, it should be 0. But what is v1? dx1 by dt. What should be v2? dx2 by dt. If it is moving by a distance x1 in t second and it is moving with a distance x2, dx2 in dt second, same time, it should be 0. So, what we got? m1 dx1, it should be minus m2 dx2. First particle move a distance d. If second is moving a distance d1, d1 should be minus m1d by d1. Minus is in opposite direction of d. If d is moving in this direction, d1 is in this direction. So it is only for direction. So distance should be m1d by, it is m2, it is m2, it is m2. We want to calculate d1, it should be m2. m1 d1 upon m2. So what is d1? m1d upon m2. So we are going with option B. So in this case, B option was correct. Next is from 2009 AIPMT. What is given? Two bodies of mass 1 kg and 3 kg have position vectors I plus 2j plus k, and for second minus 3i minus 2j plus k respectively. The center of mass of this system has a position vector. Now they gave one direct problem. You know the formula for RCM. It is m1r1 plus m2r2 divided by m1 plus m2. What is m1? 1 kg. What is r1? I plus 2j plus k. What is m2? 3 kg. What is r2? Minus 3i minus 2j plus k by m1 plus m2. So what we are getting? We are getting RCM should be equal to 1 into I and it is minus 9i. So I cap minus 9i cap. Collect j terms. 2j from first bracket minus 6j from second bracket. K from first bracket and plus 3k from second bracket divided by 4. So in this way we are getting our answer. What should be your answer? RCM should be equal to minus 8i cap minus 4j cap plus 4k cap divided by 4 means minus 2i cap minus j cap plus k cap minus 2i minus j plus k. So we are going with option A. A very direct problem from exam 2009 AIPMT. Next, a ring of mass m and radius r rotate about an axis passing through its center and perpendicular it to its plane with angular velocity omega. Its kinetic energy is, what they are saying, it is pure rotational motion. No role of translatory kinetic energy. So in this problem, whole kinetic energy is in the form of rotational kinetic energy. So we will go for kinetic energy. Whole kinetic energy is associated with rotational kinetic energy. And we know the formula, half I omega square. Since it is a ring and center axis of rotation is passing through its center and perpendicular to the plane, so what we remember in that 8 formulas, it is that only, half for ring mr square, for disk half mr square, for ring it should be mr square. And now what is given, we will do that. 1 by 2 means 0.5. Mass they are saying m, small m. Radius they are saying r square. Omega they are saying omega square. So we are going with A option, 0.5 m, no A, 0.5 m r square omega square. So we are going with B because we need r square. So we are going with B option. Next, it is from 1990 AIPMT. Moment of inertia of a uniform circular disc about a diameter is I. The moment of inertia about an axis perpendicular to its plane and passing through a point on its rim will be. Passing through a point on its rim will be. See, don't be in hurry because problem is not tough, but they are confusing you by the language. See, it is a disc. What you know, that is moment of inertia about an axis passing through center and perpendicular to the disc, means you know about this which is perpendicular to this disc, that. But they are given thing is moment of inertia of disc about a diameter. So first what we will do, we will use different colors. We will choose two mutually perpendicular diameters. Two mutually perpendicular diameters. Suppose I am choosing one, this, and perpendicular is this. I told you in theory portion that moment of inertia of a disc about any diameter should be same, because distribution of mass about any diameter is same. So if I am choosing this I, it should be I. Now first I will calculate about this axis. I am taking it ICG because center of gravity is there only. So first I am getting this ICG. It is perpendicular to the plane and passing through the center. So according to theorem of perpendicular axis, first I am applying this theorem of perpendicular axis. What I am getting? ICG is equals to I plus I, means 2I. But I want to calculate passing through rim and parallel to this, means there is one more theorem we have to apply. They are talking about perpendicular to plane and passing through rim, means I have to apply now theorem of parallel axis between these two axes, because I know for ICG I want to calculate through this parallel axis. So what should be I dash? I dash should be equal to ICG plus distance between these two axes MA square. I want to calculate passing through the point on its rim will be, or we can do, no need for this parallel axis, we can go directly even because mass is not given. So what we can do, we will take perpendicular to its plane and passing through a point on its rim will be. We want to calculate from this disk is like this. We want to calculate perpendicular to plane. We have to apply that theorem, but we should change. If suppose mass of this is m, we have to apply theorem of parallel axis. Without this it is not possible. So theorem of parallel axis will give first result. Theorem of parallel axis, we are apply this I dash should be equal to ICG. ICG is 2I plus m r square. Getting my point? I dash is equals to 2I plus m r square. Now what is ICG? We know ICG. If mass is m, radius is r and it is disk. So ICG should be equal to half m r square. But I got ICG in terms of 2I. So 2I is equals to half m r square. So it means m r square in this problem stands for 4I. So I will get I dash 2I plus 4I. It means answer is 6I. So we will go with option C. 8th problem, we will go with answer C. The problem was not very simple. Use of both theorems plus the formula you should know. What is the moment of inertia of disk about an axis perpendicular to plane passing through CG. So we are going with option 6I. Next, it is from 1990 AIPMT. The moment of inertia of a body about a given axis is 1.2 kg meter square. Initially the body was at rest. In order to produce a rotational kinetic energy of 1500 joule, an acceleration of 25 radian per second square must be applied about that axis for a duration of, they are asking for how much time we should apply that torque which is producing angular acceleration so that we will get a kinetic energy of 1500 joule. What is the formula for rotational kinetic energy? For rotational kinetic energy, formula is half I omega square. If you want 1500 joule, what should be omega? First we will calculate that. It means omega square should be equal to 1500 into 2 divided by I. What is moment of inertia? 3000 divided by I is 1.2. Remove this decimal. 12 2s are 24, 6 60, 12 5s are 60. It should be 2500. So omega is equals to 50 radians per second. It means if you want 1500 joule kinetic energy, omega should be 50 radian per second. But they are saying initially it was at rest. So omega naught was 0. You want omega 50. And for this purpose you apply a torque and give a angular acceleration 25 radian per second square. You want duration of time. Equations are there. Omega is equals to omega naught plus alpha t. Omega is 50. Omega naught is 0. Alpha is 25. T is t. This implies t is equals to 50 upon 25 means 2 seconds. So you have to apply this angular acceleration for a duration of 2 seconds. So we are going with option B. Next, it is from 1990 AIPMT. A flywheel rotating about a fixed axis has a kinetic energy of 360 joule when its angular speed is 30 radian per second. The moment of inertia of the wheel about the axis of rotation is, what they are saying, a flywheel rotating about a fixed axis has kinetic energy. We know that what is kinetic energy. First we will write what the things are given. Kinetic energy SI unit 360 joule. When its angular speed is, means omega is given, 30 radians per second. We want to calculate moment of inertia. Formula used, kinetic energy is equals to half I, because only rotational motion is there. Only rotational motion is there. So K is equals to half I omega square. It means I should be equal to 2 times of kinetic energy divided by omega square. So 2 into 360 divided by 30 into 30. Cancel 0 with 0. 3 12s are, 2 15s are, 3 4s are, 3 5s are. 4 upon 5 means 0.8 and unit in SI unit kg meter square. So we are going with option C. Next, again a very good theoretical problem from the exam 1993. In a rectangular ABCD, BC is twice of AB. The moment of inertia is minimum along axis through. Options are BC, BD, HF and EG. We know that moment of inertia depends upon the distribution of the mass, because it is sigma m r square. So if distribution of mass is very near to your axis of rotation, moment of inertia will be less. If mass is distributed at a big distance from axis of rotation, moment of inertia should be large. So clearly picture is very clear कि whole mass is nearer to EG axis. If we choose axis of rotation EG, maximum mass is at low distance. If you are going for BD, C is at a large distance, that 8 point is also at large distance. If we are going for BC, whole sheet maximum portion is at large distance. HF, again distances is too much because length is greater than width, double. If we are going with EG, the distribution of mass is nearer to the axis of rotation and we will get low moment of inertia. So we are going with option EG, all game of distribution of mass. Next, the ABC is a triangular plate of uniform thickness. Mass is uniformly distributed over the plate. The sides are in the ratio shown in the figure. Means biggest size length is B, then AB, smallest is BC. Moment of inertias are IAB, IBC and ICA. About AB, BC and CA. Which one of the following relation is correct? Again, it is the case of distribution of mass with respect to that axis of rotation. So it is very clear that mass is, you check for which axis, means we will calculate for all three axes. If we are choosing AB, this C, this mass is at a large. If we are choosing BC, these distances are 4, big distance. For AB, 3 is less. For AC, again, this point is at a big distance. So it means if we focus on distribution of mass, which should be greatest? From BC, distance is 4. So it should be maximum for BC. After BC, AB should be there because mass is at a big distance, it is 5. Smallest for AC, smallest for AC, because from this distances are less. You can plot the lines. You will get length less. If you will take this, these lines are very big in this way, big lines. Lengths of lines will show you which is less, which is greater. So it should be less for AC. Means it should be in this order. So we will go for D. IBC should be greater than IAB. Again, same problem was this. Next, the moment of inertia of a disk of mass m and radius about an axis which is tangential to the circumference of the disk. The moment of inertia of a disk of mass m and radius should be given r. About an axis which is tangential to the circumference of the disk and parallel to its diameter. It means it is disk and it is suppose 1 diameter. We want parallel to its diameter and tangential to its circumference, means target is this. We want to calculate moment of inertia about this axis. So first we should know about this axis because it is also passing through center of gravity. We can apply theorem of parallel axis. But we know the moment of inertia about an axis which is perpendicular to the plane of this. So choose two perpendicular diameters. Moment of inertia about both should be same. And we know the moment of inertia about an axis passing through center of gravity means center and perpendicular to the plane of disk. What was the formula? Which we learned that 8 formulas, half mr square, half mr square. So ICG, according to theorem of perpendicular axis, should be I plus I. This implies 2I is equals to ICG. 2I is equals to ICG. So we can write I is equals to half of ICG means half mr square. So we are getting 1 by 4 mr square. It was theorem of perpendicular axis. Now we are applying theorem of parallel axis. I dash should be equal to I plus mr square. And what is I? 1 by 4 mr square plus mr square. So what we are getting? 4 plus 1, 5 by 4 mr square. So we are getting 5 by 4 mr square. Next. Now it is a problem from 2000 AIPMT. For the adjoining diagram, the correct relation between I1, I2 and I3 is I is the moment of inertia. Again we have to check the distribution of mass about which axis should be greater than, because moment of inertia only depends upon distribution of mass. What is I? Sigma mr square. So we can see the effective distance of mass from I2 is greater than the effective distance of mass from I1. So in this case, I2 should be greater than I1. So we will go for option B. We will go for option B. Next, a circular disc is to be made by using iron and aluminium so that it acquired maximum moment of inertia about geometrical axis. It is possible with, again problem is of same type, which material should be nearer to the axis of rotation. We know that the density of iron is greater than the density of aluminium. Iron atoms are heavier than aluminium atoms. Density is more for iron. Density for iron is greater than the density of aluminium. So dense material should be at a large distance if we want maximum moment of inertia. So it means outer portion of circular disc should be made of iron. So we will go with which option? This sheet of iron is used at both external surface and aluminium sheet as internal layers. So we will go for D. Next, the ratio of the radii of gyration of a circular disc about a tangential axis in the plane of the disc and of a circular ring of the same radius about a tangential axis in the plane of the ring is, it should be tangential. It should be tangential. So how to calculate? I told you. If you know the moment of inertia of any given figure, equate it with mk square. You will get radius of gyration. K is known as radius of gyration. So first we are talking about circular disc. It is a circular disc. About a tangential axis in the plane of the disc means we want to calculate moment of inertia about this axis. It is a disc. What to do? First we will calculate moment of inertia about a diameter which should be parallel to this. So for this diameter, suppose moment of inertia about this diameter is I dash. We will choose two perpendicular diameters. For both moment of inertia should be same. And we know that moment of inertia about ICG and perpendicular to the plane of disc, we know the formula half mr square. By theorem of perpendicular axis theorem, we know that ICG should be equal to I plus I dash plus I dash. So 2I dash is equals to half mr square. So we are getting I dash is equals to 1 by 4 mr square. So now I am applying the theorem of parallel axis to get this value of I. Now I am going with theorem of parallel axis. Theorem of parallel axis. I is equals to, since diameter is passing through ICG, so we can take that I dash plus m, mass of disc, distance between two parallel axes, mr square. So what we are getting? 1 by 4 mr square plus mr square. So we are getting 5 by 4 mr square, 5 by 4 mr square. But we want to calculate radius of gyration. So we are equating this with, it is for disc, 5 by 4 mr square. Cancel m with m. So for disc, kd square, square of radius of gyration, is 5 by 4 r square. Now we will go for ring. We will go for ring. Now it is a ring. For which axis we want to calculate for ring? Same radius about a tangential axis in the plane of ring. Same thing is again there. We want to calculate about this. Same we will do. We will choose two perpendicular diameters. One is parallel to this. And we will apply ICG is equals to I plus I. Theorem of perpendicular axis. In case of ring, it is mr square. So what is I? I is half mr square. Now theorem of parallel axis. Theorem of parallel axis. What we are getting? Half mr square. We are taking one axis parallel to diameter. Diameter is also passing through CG. Half mr square is equals to, half mr square means ICG plus mr square, m a square, a is r. It should be I dash. In this case, I dash is equals to 3 by 2 mr square. So now we are going to calculate radius of gyration, means m, it is for ring, it should be equal to 3 by 2 m r square. Cancel m with m. So what we are getting? Radius of gyration square is equals to 3 by 2 r square. But we want to calculate the ratio of radius of gyration, means first we will calculate kd square upon kr square. What we are getting? Kd square was 5 by 4 r square divided by this, means into 2 by 3 r square. Cancel r square with r square. So we are getting 5 by 6. So what should be the value of kd by kr? So kd by kr, it should be equal to root 5 is to root 6. So we will go with option B. We will go with option B. So now in next slides, we will discuss remaining problems.